So yeah, it's great to be here. Thank you for taking time to listen to this talk. My role is only to introduce Authentise and Anusha very briefly. So just so you know what we do, we build workflow management and automation software. Imagine it as a tool that allows you to take an order in, see it being processed through all of its stages, and provide it to shipping. We got connectivity to a lot of different devices, which is what partially what this talk is about today. So we take the data from the machines to automate certain actions like quoting, or like order status updates or more. So that's what we do on a day-to-day basis. As I was just said, I also speak at Singularity University quite regularly. And what is very helpful in those situations to encourage people to participate and get excited is to share these giveaways. Each card in this card deck has a different application on 3D printing on it, and they're completely unique cards. So if you heckle, or you question, or you do anything of that kind, I'll give you a deck of cards. Please don't heckle Anusha, because speaking is not her main gig. So you don't want to make her more nervous. Anusha is one of our software engineers. She's a senior software developer with Authentise. Got a master's in computer vision, so she's on the machine learning side, and it's been great to work with her now. 2 years?
Yep.
Yeah, based in Utah, as our team has been, and she'll talk about the technical stuff much better than I possibly could. So I'm going to hand it over to her. Is that a good enough introduction?
Yep.
Great.
That's
thanks.
awesome. Okay, I'll just go up actually. So yeah, so like Andre mentioned, we are into softwares for additive manufacturing. We are trying to automate as many things as possible to help industries manufacture scalable products. So additive is now production scale. Invisalign, one of the companies, is actually creating about molds for about 1 billion parts. GE, on the other hand, it's creating turboprop engines, which actually reduces the part count by 98%. BMW is trying to create metal parts for its cars, which means so many things are getting printed, which means scalable production. So over these years, we have observed that industry is now going towards scalable printing. About 36% of the industry is all about scalable production. But the current processes are not able to keep up with it. For example, for tracking, we still have technicians or employees who are actually spending time tracking whether the process is complete or not, whether it failed or what happened to the jobs. Packing, we have advanced softwares, but still we need some people to actually make sure that whether we can print that in the printer or not. And there are several more applications. Taking some real life examples, these are some of the examples that we got from some of our clients. For example, in the operational transparency, we see that we need technicians who actually take care of what the process is going through, where the process is at, tracking it, and so on. Coding. Coding for complex models takes approximately 10 to 30 minutes, taking it from different manufacturers, third-party services, and so on. Quality assurance. In order to make sure the quality of the product, we have at least one employee who actually takes care of compiling the traceability report of the process. So all of these, there's so many things happening with the scalability in the production, the more things are getting printed, and hence, if we invest on these resources, it's actually costing us so much per year, which is a huge number. It doesn't have to be like that. Additive actually gives a lot of data from different processes possible. And we can actually use this data in a smarter way to maybe predict, see for patterns, and so on. And the other thing about additive is that it's greenfield. It doesn't have a lot of legacy processes to encumber on. So let's see what we can do with the data that comes in from additive and if we can use it in a better way. So when I say data coming from additive, in additive, I'm not just talking about like machine data. That is definitely a major part. But there's other data which comes in, like maybe from manual processing, like if the technician is actually creating the traceability report, we can definitely take that data. Other things like sales, customer feedback, and just the process from printing to shipping. There's so much going on in additive manufacturing. So if we can use this data, the challenge is actually about how do we get this data and how are we going to use it in order to come up with some pattern that the machine can learn. In this talk, we are basically going to concentrate on one of the applications, which is going to be quoting. Me as a developer, when I'm like just sitting in my office and I want to print some really cool model, even before doing that, the main things that I want to know is how much time is it going to take to print that model. The second thing is I want to know if I have enough material to print that model. So that's just like me maybe printing once a month. Just scaling that up for the industries, there are definitely so many problems that come across, like time sensitive. The coding for complex models actually takes some time. Accuracy. We need to code accurately in order to make sure that there's enough inventory in place for keeping the process going. Lots with the scalability in printing, so many things are getting printed. So yeah, that definitely comes across as a problem. Like, okay, I'm not just printing cubes, like 1,000 cubes per day. I'm printing different types of different shapes and different models with different materials per day. So that poses the problem of so many coding. Sorry, yeah.
When I'm doing coding, the biggest variable I have is post-processing. I don't always know how long it takes for me to pour or take powder out of the part. Are you addressing that?
Sorry.
Shall I take that question?
Yeah,
Because
sure.
I have an answer to that. Thanks for the question. Sure. So we do the same model that Anusha is describing here also applies to all the post-processing steps. And the only thing we don't do right now is we don't capture the time it's taken for historical models. We get the data for how long it's taken to print historical models because we get that from the machine. But for post-processing, you have to barcode, you have to scan in and out at each workstation. And so we're not capturing that information. But as soon as you do that, the same model that Anusha is describing for printing also works for post-processing. Okay, does that make sense?
That does. Thank you.
Great.
Awesome. So yeah, there's so many things, right? Like you mentioned, post-processing, and maybe even for shipping, people might want to know how much time is it going to, for me to get the model once I order the model, right? So some of the solutions that we're going to talk about is just speeding up the process with by using the data in hand, and then making sure that the accuracy increases with time. Yep. So at Authentise, these are different approaches that we have used so far, and so this is just an ongoing process. I'm not saying that okay, we are there yet. Like okay, we have the most accurate results. No, this is just the process, and we are still accumulating data so that we can come up with better results. So in the first take, what we did was we just took the model volume and actually estimated that as the material that will be used in order to print it. So the problems with that was like most of the time it was overestimated. Of course, when you're trying to print a model, it usually has an infill which actually varies, right? The second thing that we used was tool pathing. So there are definitely a lot of tool pathing softwares, slicing engines, but the only thing was not all of them are like open source, and it is definitely expensive to integrate them with the application. The third that we are using right now is machine learning. We are trying to extract data from several sources and actually trying to use them in a better way to find some patterns. So what and how are we doing that? We're trying to get some data to train the machine to find some pattern. So what is the data that I'm really talking about? First is the machine data. The printer itself gives out so much information in the form of log files. So just passing that kind of data. Then selecting the predictive model once I have the data in hand, which will completely depend on what question am I trying to solve. Am I trying to solve a question like, can this model be printed or not, which is going to be more like a classification problem, or am I trying to solve, just in this example, like quote some material used or the time for the print to take place, which is going to be more in the side of regression problem. So once I select all that and I actually implement this, how am I going to interpret the results? So that is going to completely depend on what actionable insights can I infer from it. And by actionable insights, I mean as a data person or a developer, I might just apply a model to make sure that I get some good accuracy. So those are just numbers, but how do I actually tell it to a business user? What matters to a business user? The business user might just, all he might care about is like, can I really schedule this job or not? How good can the job scheduling work? So that's the ultimate goal. That's how we are going to interpret the results. From the different models that I tried, from the time we got the data to we are increasing the number of features. We first just used the volume and surface area, and then we went about getting the results, and then we started by increasing the number of features and then extracting the material and time it will take. So from the past and the present, from the model that just used volume and surface area, which was available from tool pathing and other slicing engines, to the current that I'm using right now, which is adding more features, which I'll talk about in the next upcoming slides, is that there was a slight increase in the accuracy. If we see here, there is some increase in the accuracy from the past results and the present ones, whereas there's definitely not all the predictions are accurate. The similar is with the material use. We do see some accuracy, but not everything is like perfect. So what did I use? I used random forest regression in order to do this. And some of the features that we have used right now with the data that we have available are just the machine type. We had like Fortis 450 and 900 material that we used to print these. And then the surface area volume, which are some of the major components that affect the material used. And the interior, like whether it's going to be a solid or sparse material. So all of these are categorical data. And the slice height of the print process itself.
I'd like to ask about the data that you have. Do you know what kind of causes that, what kind of errors, like the errors that you have in the data? Do you know what caused them? Or like?
Yeah, so one of the things was that the data set is not large enough. We are still acquiring the data. So it was in the range of like just for 500 models. So I would say that it couldn't learn the model so well because it was in a wide range, starting from 5 millimeter cube to 5,000 millimeter cube. So it was in that range. So I would say it didn't learn it properly in order to predict the results.
So one is that it will increase the accuracy. What we're confident in, because we've seen it in the data, is that our approach does yield a more accurate estimate in the time and material it takes to print than our previous model, right? The only more accurate way of doing this is to create a toolpath machine right now. We believe that over time, with more data, and extracting more features that Anusha just mentioned. We're just looking at 6 right now. We could look at dozens more. We can get to an even more accurate model, and we expect it to beat the toolpathing engine in the future. But the confidence, the reason we're presenting here today is that we gain confidence that we know our machine learning approach is valid, and that it drives more, that the more data we get and the more features we extract, the more accurate our predictions. Yeah, it's on that path, right? As Anusha said, 500 data points aren't enough. Machine learning is usually done on billions of data points, right? So,
where are you guys getting the data from right now?
From our clients, so they use our MES system to process all their orders from incoming orders, and we track and we actually get the machine data back and tell us how long it took to print those orders. So we have that information is in our catalog now. The clients can also decide to deploy on premise, so in that case we won't see the data, but the clients that choose to use our cloud, we get data from them.
So,
yeah.
Sorry, there's a lot of cards. No, sorry.
So my question, I mean, it's a great approach, but like you said, data learning works the more data points you get.
Yeah.
So now, are you further classifying the drawing data into hashing area versus contouring area rather than just inputting the volume and surface area?
So right now, I would say that it's just this much because that's the only data we have in hand. We have not gone with more complex algorithms. It's
because one thing, if we feed the same part into like a concept like the M2 machine versus a 3D System Pro X350, it would be different.
Yeah,
right.
Machine type is one of the features extracted. Right?
Yeah.
So we are looking at machine type.
Also, machine type is not just PVLS, but which model, which system.
Right.
Which system, yeah.
So that's going to be completely categorical, and that will definitely affect the estimation.
Yeah.
You don't have any problem with the time you train this machine. For example, for any certain of printing. So I think you need time.
Yeah.
Big time to train the system, right?
Better computational power, right? That's what you're talking about. Yeah, I'm sure we'll come across that in the future. I'm sure that will be, but right now we are still in the place wherein we are gathering data, so we are yet to go there, and when the time comes, we'll have to deal with that for sure.
But also, this computation for training the model happens in advance. So the actual time crunch where we need to deliver results quickly is using the trained model to predict future growth, right? So we create a model in the back end. We're not time sensitive on model creation. We're much more time sensitive on using that model to predict future outcomes, which is not required. We don't need to build a new model for that. So, right? Does that make sense? Okay.
I was just curious what type of statistical software you're using primarily for your.
So right now, this is not actually deployed. So this is completely a prototype. So I'm just using pandas to work on.
Pandas.
Yeah. So that's what I'm using. But once we'll be deploying it, we'll have to come up with.
Solution
Yeah.
I see. Cool. Thank you.
Okay. Sorry. Okay. So yeah. So the next approach that we are planning to take is actually talk. So one of the products that we have is actually machine analytics, which is talking to different kind of printers. The printer gathering printer logs and actually parsing that information to gather useful features and values for those. So that is something that we would expand more in order to get more data. Apart from that, more relevant features like right now we don't really have the infill percentage that I'm using, which I think will really help improve the estimation. And there are several more factors like extruder specific speed and temperature and a lot more things. That is something, if added, would definitely improve the algorithm. So these are the 3 approaches that we have taken, and we feel that the more the data we get in the future, better the algorithm we can use in order to predict. So the problems with some of the approaches like tool pathing was that if the model itself had some kind of problems, the tool pathing would have some processing error for us. So it was not always reliable for us to do a deployment time estimation for that. So that is why we are planning to move towards this, but it's a long way to go. We need to gather more data in order to find better results. And the most important thing would be actually to just look at the statistical importance of all the features and what actually needs to be included versus removing the redundant features. Where are we going next? I would actually like Andre to continue, and he is an expert, so he can actually take it.
Well done, Anusha. Thank you.
Yeah.
As Anusha said, I think where we're going with the model creation is to extract more features, as she described, and to make the model more accurate, deploy it in the service. 5 more minutes, great. And then the next step after that is that process inherently requires us to identify which features might be an important determinant of print time and print and material time. So in reality, we're acquiring, per print, we might acquire 400 different points of data, maybe 500, right? Anything down to how long did the engineer take to pre-process a design file, for example. So we don't know which of those factors might actually influence print time. We could deploy neural nets in the future to determine that for us, right? So actually allow the machine, the data to tell us which features are important in determining print time. And quoting or print time and material estimation is just the first step. There are many other applications that a very similar approach can be applied to, whether it's consumable estimation for all the post-processing steps that were mentioned, or time estimation, inventory management, your nesting process, the build and support. Each of these steps in your production process could benefit from a very similar approach, right? It's not just about quoting, it's about many other things. So that's what we're going to start working on. And this is not a conclusive list, exhaustive list. This is just a few things. And one of the things that we have started working on very lightly with Oak Ridge and with others is the last one, is quality certification. So our general thesis is that we manage the entire workflow from geometry down to shipping. And as a result, we should be acquiring all the data necessary to make a determination on quality. So we expect to get to a point where the machine learning algorithms that we develop at least allow us to reduce the incidence of testing, for example, in metal print, right? So, and that's the overall gain that the machine learning right now, quoting, it's interesting, but it becomes a lot more interesting once you start determining quality from that, because that would then also allow us, that's really a precursor to distributed manufacturing. That's what we need to start decentralizing the production systems. And we started doing that. So the way we started doing that is in the production process with generating traceability reports. And so as a first point of call, all the data that's generated, whether it's the geometry changes, the change that the operator made, the data that's coming back from the devices, the 500, in HP's case, I think there's like 100 megabytes per print that we get. All that data floats into one central report. That's the first step. Like, can we have a data lake that we can actually start tapping into? So that's interesting to us as a first point of call. And on top of that, as I said, Oak Ridge and other people, other partners working on algorithms that could use some of that data to determine that quality. So that's where we're going in that strategy. If you guys want to get started, pretty easy. Some machine manufacturers allow you to get that data. Some have platforms or programs, like EOS has EOS State Everywhere, that allows you to get the data by API. A lot aren't open yet, so all the OEMs in the room, if you're not sharing your data, you're doing something, you're really hurting yourself. Share the data. In those cases, we just hack the machine most of the time. I mean, it's not, so there's two data flows into a machine. One comes out, which is what we've been talking about, and one is going in, so sending data into the machine. The second you don't want to hack, because that might invalidate the warranty of the machine. The second is, doesn't matter. It's not really even hacking. It's a database that's open. You just have to approach it in the right way. And also, don't forget the non-machine data, it's supposed to say. Geometry, post-process device, the process data yield a lot of information about that you could use in that process. We also, as Anusha mentioned, in addition to our MES system, we have the connector to the machines that you can buy separately if you don't want to use that. It's called machine analytics. So yeah, thank you very much, and thank you for all the great questions. Appreciate that.